What factors determine actuator choice in control system design? Imagine building a robot or a machine that moves exactly how you want it to. Choosing the right actuator is like picking the perfect tool for a specific job. It's not just about what looks good or costs less. It's about matching the actuator's features to what your system needs to do. First, think about the kind of motion you need. Do you want something to move in a straight line? Then a linear actuator is your best choice. If you need rotation, then a rotary actuator makes sense. For back and forth movements, oscillatory actuators are ideal. Picking the right motion type is the first step to making your system work smoothly. Next, consider the load and force your actuator must handle. If your application involves heavy lifting or pushing, you need an actuator with enough force or torque. For lighter tasks, smaller and less powerful actuators will do. Knowing the maximum force or torque required helps prevent choosing an actuator that is either too weak or unnecessarily overpowered. Another important factor is how far or how much the actuator needs to move. This is called the stroke length or displacement. If your system needs to move a part 10 centimeters or a meter, the actuator's stroke must match that distance. Using an actuator with too short or too long a stroke can cause problems or inefficiencies. Speed is also key. How fast does the actuator need to reach its position? Some systems need quick responses, while others can move more slowly. The response time, including how quickly it accelerates and settles, impacts how precise and responsive your control system can be. Precision and control are vital in many applications. If you need your system to position parts exactly every time, choose actuators with high accuracy. Features like feedback devices, such as encoders or potentiometers, help monitor and control the position precisely. This is especially important in robotics where exact placement matters. Energy source and efficiency also influence your choice. Electric actuators are popular because they are energy efficient and easy to control with electronic signals. Pneumatic actuators use compressed air and are cheaper but might use more energy overall. Hydraulic actuators can handle very heavy loads but requiring complex fluid systems. Picking the right energy source depends on your budget, environment, and power availability. Control signal compatibility is another factor. Electric actuators respond to voltage or current signals, while pneumatic and hydraulic actuators respond to pressure or flow commands. Ensuring your control system can communicate properly with the actuator avoids extra work and potential issues. Environmental conditions matter too. Will the actuator be exposed to dust, moisture, or extreme temperatures? If yes, you need sealed or corrosion-resistant models. For outdoor or harsh environments, selecting the right protection rating ensures your actuator lasts longer and performs reliably. Space constraints can't be ignored. If your system has limited room, choose compact actuators that fit without trouble. Mounting options are also important. Flexible mounting makes installation easier and more adaptable. The ability to connect seamlessly with your control system is essential. Actuators that work well with programmable logic controllers or other automation devices make programming and operations smoother. Finally, think about cost and maintenance. While cheaper actuators might save money upfront, they could cost more in repairs or replacements later. Reliable, durable actuators reduce downtime and keep your system running efficiently over time. In real-world applications, these factors come together. For example, a robotic arm needs precise, fast, and compact electric actuators with feedback. A conveyor system might use electric actuators for precise positioning or pneumatic ones for quick, repetitive movements. To sum up, choosing the right actuator involves matching the motion type, load capacity, speed, accuracy, energy source, control signals, environmental resistance, space, and cost to what your project demands. When you get this right, your control system will perform better, last longer, and be easier to manage.